Alright guys, today's goal, the learner will understand how to use model inverse and joint variation and graph basic rational functions. Two variables x and y. So you have learned two variables x and y show direct variation if y equals a times x for some non-zero constant a. Another type of variation is called inverse. Two variables x and y show inverse variation if they are related as follows. Y equals a divided by x, where a cannot equal 0. See, non-zero. The constant a is the constant of variation, and y is said to vary inversely with x. So it says, tell whether x and y show direct variation, inverse, or neither. So I ask, can I write it y equals ax or a divided by x? This one looks like y equals ax because a would be 3, so this is direct. Here I have x times y equals 0. It looks like neither, but I got to solve it for y. See how it has y equals right there? 0.75 over x. So that is inverse. And see how there's that plus or minus? That sign right there means neither. Because see, do you see plus or minus anything here? No. Okay. So let's look at these. It says the variables x and y vary inversely. So that means this. Use the given values to write an equation relating x and y. Then find y when x equals 2. Okay, so it says x equals 4, y equals 3. See how it said varies inversely? Solve that for a. So I get a equals 12. So I have this equation, y equals 12 divided by x. So if I plug that in, y equals 12 divided by 2, y equals 6. So there's my equation, there's my answer. I didn't need this. There's my circled answers, okay? So there's the inverse variation. Now joint variation occurs when a quantity varies directly with the product of two or more other quantities in the equation below. So see how it says z varies jointly with x and y, and it's z equals a times xy. P varies jointly with q and r, so p is what it equals. Q, r, s are the other three. So let's look at these. It says the variable z varies jointly with x and y. So that means I'm using this one. Use the given values to write an equation relating x, y, and z. Okay, so if I plug this in, I get 7 equals a times, well, let's put them in order, 1 times 2. So 7 equals 2a, so a equals 7 over 2. Then find when x is negative 2 and y is 5, so here's my, well, first let's write the equation. Y, or not y, I'm so used to y, but it's z in this case. Z equals 7 over 2 times xy. So there's part one. Then find that. So z equals 7 over 2 times negative 2 times 5. Negative 35. So there's the other part. So let's try this again. 56 equals a times negative 6 times negative 4. I'm just filling in to this equation. 56 equals 24a. Divide by 24. So I get, oh, that's going to be a fraction. Let's see. 7/3. So then plug it in. So here's my equation first. Z equals 7/3xy. So Z equals 7/3 times negative, oh, not -6, times -2 times 5. So Z equals -70/3. So there's inverse and joint variation. So write an equation for the given relationship. X varies inversely with Y and directly with X. So hold on a sec. This is supposed to be W. Okay. So if we go to write this, it says X varies. So X equals, you have A, you always have A, inversely with Y, that's on the bottom, directly with W, that's on the top. So P varies jointly with QR, so A, Q, R, and inversely with S, divided by S. So there's our equations. We need to understand what those mean. So there's the direct, inverse, and joint, okay? So now graphing rational functions. A rational function has the form f of x equals p of x divided by q of x, where px and qx are polynomials. And q of x cannot equal 0, because remember, denominators cannot equal 0. The inverse variation function, f of x equals a divided by x, is a rational function. So what we just learned about is a rational function. The graph of this function when a is 1 is shown below. So here's the parent function. F of x equals 1/x. See how there's two asymptotes, a vertical and a horizontal? Okay. We're going to have to learn how to always find those. Okay. And then hyperbola, which consists of two symmetrical parts called branches. The domain and range are all non-zero real numbers. Okay. What that means is they can't equal 0. So the way we would write that, negative infinity to 0, 0 to infinity, and that is for both domain and range. Okay? Alright, so there's the parent function. See how it has, these are always going to be opposites, so it also could be this. And that's when a is negative. Okay? So, graphing translations of a simple rational function. The graph of a rational function form, y equals a divided by x minus h plus k. Follow these steps. Step 1, draw the asymptotes x equals h and y equals k. 2, plot the points to the left and to the right of the vertical asymptote. Draw the two branches of the hyperbola, 1, 2, as the plotted points approach the asymptotes. Okay? So let's try this. So it says graph the function. So step 1 is to graph the vertical and horizontal. So remember, it's x equals h, y equals k. So I get x equals 0, k equals 0, so right on the axes we have the horizontal and vertical. Now, you can go ahead and put this in your calculator if you want. But what I would do, pick two numbers you can divide by 4 to the left. So I'm going to go -1, -2, and then +1, +2. But if you want to, you can use either left or right of the vertical asymptote, which is 0. So I went 1, 2, 3, 4, 5. 1. Let's do this. If I plugged in -1, I'd get 4, 2. So -1, 1, 2, 3, 4. -2, 2. If you need to, you can pick another one. So if I plugged in -4, I'd get +1. So it's going to look like this. If I plug in 1, I get -4. Plug in 2, I get -2. So there it is. Okay. Let's try another one. So let's see. I need x equals h, which is 3, y equals k, which is 2. So at x equals 3, I draw the vertical. At y equals 2, I draw the horizontal. Now I need to pick numbers to the left and to the right of the 3. So I'm going to pick one and 2 and 4 and 5. You can use your calculator if you want to get them. Okay? So like if I put this into my calculator now, I go to my table. If I plug in 1, I get 1.5. If I plug in 2, I get 1. If I plug in 4, I get 3. And if I plug in 5, I get 2.5. So if I look at these, I go 1, 1.5, 2, 1. So it's going to go, and then I get 4 and 3, and 5 and 2.5. So it's going to go like that. Okay? So remember, find x. For standard ones, you find x equals h, y equals k, you graph those. You always have to graph those. If you don't graph them, they will be marked incorrect. Alright, so other rational functions. So they don't always have this form. So when they get to this, all rational functions form y equals ax plus b divided by cx plus d also have graphs that are hyperbolas. The vertical asymptote of the graph is the line x equals -d divided by c, because the function undefined when the denominator cx plus d is equal to 0. So set the denominator equal to 0 and solve. The horizontal is a divided by c, so these two divided by each other. So if I look, y equals -3 divided by -1, which is 3. So I can go to 3, draw the horizontal. To get the vertical, -x minus 1 equals 0, so -x equals 1, so x equals -1. So at x equals -1, draw the vertical. Okay. So pick -3 and -2 and 0 and 1. See how I went to the left, to the right? So plug this into your calculator. Make sure you're using parentheses to group the top and the bottom. And then look at your table. So I got 5 and 7. So if I go -3, 5, -2, 7, it's going to be this. And then 0, -1, 1, 1. Going to be that. If you don't get your graphing calculator to show you that, keep using parentheses until you get it to show you that. That is the correct graph. Okay? So be ready to do some work. See you guys.